So welcome to our final Zoom session. We're into our week 6 of all of our sessions, and I know many of you have either watched each of these sessions live or participated live, or you've watched the recordings. And I thank you all for joining us for this whole time. Hopefully you've gained some new snippets of information that you can use as you're working with students, whether it's finishing out this school year or as we pick up the next school year. I know that many of you are finishing up your last week maybe with students, or maybe you finished last week with students, but you're still finishing up that school year. So before, I just want to open a couple of things for myself so that I can see what's going on in the background. So we're going to work on looking at a few other routines and kind of how students learn, and the components that students might need to support, or you might have to work to support student learning. So before we get started with those, I want you to think about, and I don't know if I shared correctly, so I'm going to stop sharing and reshare so that you can hear the sound. I'm going to play a quick video. I want you to think about whether or not you feel like you've been in this situation before with your students.
I think it's already starting.
Okay, here's your homework. First let me tell you the directions. What's 4 takeaway 5? 1, 2, 3, 4, 5, 6. Takeaway. What's 6 takeaway 1?
1.
No, you take away, so you take away 1 out of 6. How much does it equal? What's 10 minus 1?
I don't know.
1, 2, 3, 4, 5,
6.
6, 7, 8, 9,
10.
Nope. Take away 1. How much is this?
1, 2, 3, 4, 5, 6, 7.
Nope. 1, 2, 3, 4, 5, 6, 7, 8. And 8 and 1 more. And add 1 more. How many does it equal?
1, 2, 3, 4, 5, 6, 7, 8. 1.
It makes 9. See how you take away? You take away 1 and it equals
1.
Do you get it now?
Yes.
Again.
Right, so I know probably many of you have felt that way with students before, as you're trying to help them through this process, and we keep trying to kind of simplify the problem or make similar examples to help simplify for them, and they're just not getting it, and we've kind of gotten to the end of what we at that point can do, and we kind of have to step away from the problem. So I always enjoy watching those little videos like that. That makes me feel like I'm not alone, that other people understand that this happens. These are called kid snippets. They're just a video from YouTube. It's always children voicing over adults, and so it's lots of different situations, but I really like that math one because I feel like I've been there many times before. So we're going to kind of talk about where could we go for students that are struggling like that. So the first thing we're going to talk about are the teaching practices and productive struggle from NCTM's Principles to Actions. NCTM stands for the National Council of Teachers for Mathematics, and they have published a book called Principles to Actions, and they, in this book, there are the 8 mathematical teaching practices. So they're practices that, as teachers, we want to be cognizant of as we're teaching students, and that they really could apply to teaching in any content, but they're specific for math. And so when we're talking about productive struggle, this is one of those teaching practices. And what does this mean, productive struggle? It means that students are grappling with that mathematics. They really are trying to make sense of the problems. And so often, this is where we rush in to rescue students, right? We see them struggling, we want to help them work out that problem, so we jump in to try to give them hints or show them how to do the work. And really, it's about supporting that struggle and letting them work through some of that mathematics, either on their own or in a small group, because they learn from that. If you think about as an adult and working through a problem, we learn the most when we really struggle through something. We learn how to solve that or get to a solution because we've tried lots of different avenues, and eventually we succeed and we learn from that. So we're looking at that productive struggle. It's okay for students to struggle productively. Now, there is an unproductive struggle, right, where they're just frustrated beyond belief. We get tears and students shut down. But when we're talking about a productive struggle, is that they've got some pieces, they're maybe working with other students who can help move them through. They're trying out strategies, and maybe we do give them a little bit of a nudge to help them with some strategy ideas, but they are getting through to the mathematics. So new learning will come from this. Students really do learn from one another. So often it's that rescuing our students, and we want to, it's hard to leave them and let them say that we're going to not rescue them, but we really have to let them work through and grapple with that mathematics. So when kids learn, we think about those concrete examples, those areas where we can use manipulatives to model the math. We're acting out the operations. We're making sense of the numbers. So we might use base 10 blocks and cubes and counters. And so in our last weeks of work, I always jumped to our chart paper here to show you strategies. I didn't have the concrete objects here with me at home to model that, and I couldn't find a great way to model that for you in like a recorded session or in our video. So I didn't have the base 10 blocks to use or the cubes or counters to use. However, that's where we would have started all of these strategies with. We would have started with those base 10 blocks and allowing students to use the physical manipulatives to actually act out that math. We then move into the visual, so using that pictorial representation to model the math. So that's when I drew the base 10 blocks on our board here, or we made an area model that we drew out on the board. Students may use that. They may like draw the base 10 blocks. They're drawing 10 frames. They might use a number chart or cards. They might match representations, and they may bounce back and forth between the concrete and the visual. They might be using those blocks and then drawing a representation of it, so they're moving across. And then we get to this abstract piece, this numbers and symbols to represent the math, right? That's where eventually we're getting our students to standard algorithms or a procedure that they can do, but they have, if they don't have a visual or a concrete model or some connection to that problem, they're going to struggle. And I think we jumped so fast into that abstract numbers sense, like we're jumping into problem solving without using visuals or without using manipulatives, that we really have to spend more time, especially in that concrete stage, using manipulatives, even for our older learners. So often we give, our kindergarten, first grade, even second grade, some time with base 10 blocks or cubes and counters. But how often do you see fifth graders really working with base 10 blocks, or even fourth graders? That's such an important area to allow them time to work with those much longer than we would expect to see them. And even into the middle school and high school, being able to use concrete models. So it's not just for our youngest learners. And then all in the same time, we're still looking at this verbal piece. We're using the vocabulary. We're talking about the mathematics. We're having kids explain verbally. And we're giving them a context, a real world example. We're giving them situations and allowing students to make sense of the mathematics in this context. Now, we like to think that it's kind of this linear progression, and it's really not, right? It's really more like if you picture a star with these being the 5 points of the star, often we do see that concrete, visual, abstract, but many times we have to move back. And maybe we go from abstract back to concrete or abstract to visual. And all the while, we're focusing on the verbal and the context of the situation to support each of these models. So it's really a very interwoven web where we're moving amongst all of these different representations of numbers and mathematics. But it's important to know that students really do need a lot more time than we give them in that concrete and the visual and moving into the abstract. Are there questions about this kind of model of how we think about how kids learn, that they really do need some time in that concrete and then visual and abstract? Are there any questions that have come up? If not, oh, Michelle, go ahead.
No, I'm not seeing any questions at this time. Just a comment that the productive struggle is one of my favorite educational or real life terms.
Nice. So now we're going to look at a couple of other routines that could prompt a productive struggle. They might not. There's some fun, engaging routines that do have students thinking about mathematics, thinking about, some of them are very visual. Some of them are making connections between the visual piece, but it also links in verbal, because we're going to ask you to talk about the concepts within these routines. So the first one that I'm going to share with you is which one doesn't belong. And in a which one doesn't belong routine, we are given a box that has 4 images. So 4 things to think about. Sometimes they're numbers, sometimes they're pictures, sometimes they might be graphs or equations. But we're asking you to think about, out of these 4, which one doesn't belong? Well, in reality, there is actually a reason why each one of the 4 might not belong. So in this case, we'd ask students, which one doesn't belong and why do you think it doesn't belong? And so it really gets students thinking about concepts and ideas around mathematics, but also comparing and contrasting, right? They're comparing the images, they're finding what's different about them. We could use this in a whole group setting, or we might use this asynchronously. Like if you had a group that you didn't see every day, but they had access to the pictures. So maybe you were using something like Google Classroom, or maybe you just have this up on your board in your classroom or in your workspace. You have this picture up and you just ask students to think about it, and they come up and they can put sticky notes around it. But if we look at this, excuse me, think about which one of these shapes does not belong with the others. And I would like for you to share out. I know that we are a larger group, but if somebody would like to unmute themselves and tell me which one doesn't belong and why.
I would say the star doesn't belong because it's not outlined.
Good. So the star itself does not have an outline. The others all have that red outline. Who else found one?
I would say the heart, because it's the only one that doesn't have straight lines.
Good. So the heart here does not have straight lines, so it's not a polygon. The others all have straight lines.
The arrow, because it's made up of 2 separate shapes.
Nice. So the arrow is a composite shape, and it's made up of 2 separate, so the triangle and the rectangle, whereas all the others are made up of 1 solid shape.
The lower, can I say, the lower right has no color in it.
Good. So this shape here doesn't belong because it's not filled in. There's no color to it, whereas all the others have a color, are all filled in. Now, there is, the nice thing about these, which one doesn't belong, there really is no right or wrong answer, and there might be more than one reason that a shape might not belong with the others. And so it gives students the opportunity to think about what's alike, what's different, why could it not belong? And as long as you can justify why it doesn't fit with the others, then it's a correct response. So I have another one for you.
Before we go on,
Yes.
I have a question in here. It's kind of a statement. It says, I'm conflicted about the productive struggle concept because students should be given a concrete way to solve the problem so as not to learn an incorrect concept.
So with productive struggle, we're letting students work through that mathematics. And if they're on the wrong path and they're not getting there, then we might have to help ask questions and redirect their thinking. They also may be working with another student who they can be bouncing ideas off and sharing out. They may share out with the whole group. And if a student shares something that's incorrect and others might have it correct, or there might be some that don't have it right. Another strategy or routine that I've heard that some use is called my favorite no. So they look at maybe incorrect responses and the teacher might pick their favorite no, the favorite response that is incorrect. And then they work through that problem and try to figure out how it could be corrected or where the mistake was within the problem. And so I think it's important to have students also understand that we learn from mistakes. We learn from our incorrect responses. And we want students to make sense of the mathematics, and even if they've given a wrong answer, we learn from that and learn how to fix it and make it correct. Michelle, do you have more to add about productive struggle?
I do. I like this particular teaching practice because it really shines the light on becoming, as I used to say when I was in the classroom, the tour guide. I'm the tour guide for the students on their mathematical journey. And my role here is to ensure that they are engaged and enjoying the mathematics and that they're not going down a side street or taking a wrong turn, but I'm going to do it in a way that I can guide them back to the correct path without providing them with the answer. And so thinking about it through that tour guide on this great mathematical journey and questioning what they're noticing, what they're thinking, helps me better understand the misconception that they have and why they're heading down that path. And so it's a balance and it's a challenge for us as teachers and supporters of students to not put on that superhero cape and save them from evil mathematics. But we're here to support them in their learning and engage and embrace even those struggles and see as students come off the other side of that struggle and they've accomplished that goal, the satisfaction that they have really is something worth waiting for. But just doing that nice, gentle guiding as opposed to no, do it this way. And it's a challenge for us to not rescue the kids.
Thank you. All right, so our next, which one doesn't belong? This one has coins. So take just a few seconds here to look at the pictures and think about which one doesn't belong. So who has one they can share?
The nickel, because it's the only one without a group of 4.
Good. So this one here, because it's the only one that's a single coin and not 4.
The dimes, because that's the tails and the rest are all heads.
Good. So the dimes are all showing their tails, not their heads.
The pennies because of the color.
Good, the color is different. What about the quarters? Oops, sorry.
Is it 4 quarters and 1 dime?
These are 4 quarters here.
Okay.
The faces are facing the opposite direction of the pennies.
They are the opposite direction of the pennies.
Is it the size of the quarters?
They're larger than the others. Could also be that the quarters are the only one their value is $1 or more, right? That it's, so there's many reasons, we could come up with many reasons that they might belong or not. I do want to take you to the Which One Doesn't Belong website, because I want you to see there are so many different puzzles. And as students get really good at these, they may choose to make their own, and they can actually submit their own Which One Doesn't Belong puzzle. So it'd be a great way to have them, once they know this routine and understand how this routine works, they could create their own. You could use them in your own classroom, and then they can submit their own right here on this website. And I know Michelle shared the website earlier. So when I scroll down, I can actually click on whether I want to look at shapes, numbers, or graphs and equations. With the shapes, I can scroll down through. These are already pre-made puzzles. This is a free website. There are things even like shapes. How are the shapes different from, the letters different from one another under the shapes? We can get into some of these area models, the coins, and some of them are just pictures. Maps. I like the decks of cards, but you can keep going. This one's canoes, right? Like they're just very basic pictures that we look at for things that are similar and things that are different. If we go back and go to numbers, there are numbers. So in a puzzle like this, these are all square numbers. This one is not a square number. This is the only even number. This is the only single digit number. It's also the only one that the digits do not add up to make 7. This one could be, trying to think of a reason.
The only one divisible by 5.
Yeah.
There you go. That's a great solution. Sometimes they're just as simple as what can you think of that will work? Good. But then it gets to be some very more complex kind of numbers. I love when we get working with the clocks, especially the analog and digital clocks. We get fractions mixed in here, some of the dominoes, but then you get into equations and just other ways that numbers are represented, patterns of numbers. And then the final one is graphs and equations, most likely for our upper level learners, not so much necessarily elementary school, but you even get into some equations of lines within the graphs. So that one is the Which One Doesn't Belong routine. It's a great one, just engaging for students because they really want to figure out which one doesn't belong. Now, let's see, back to our slides. The next routine is Would You Rather, and the website is wouldyourathermath.com, and we'll get that in the box in just a moment. So in Would You Rather, you're given 2 options, and you have to think about which one would you rather and why would you rather that option. And again, this is one of those routines that there isn't necessarily a right or wrong answer. It's really about the justification that you give for which one you would rather have. So when we think about this problem, would you rather have Cheez-Its to cover a rectangle with a length of 9 and a perimeter of 22? So we start thinking about some area models and the the perimeter is 22. If one side is 9, that makes it a 9 by 2 rectangle. And then if we think about this one, a length of 5 and a perimeter of 20. Oops, sorry, got clicking here. The length of 5 and the perimeter of 20, that means that it is a 5 by 5 rectangle. So when we think about, we can think about the length and the perimeter, the areas of these would mean the amount or the number of Cheez-Its maybe that we have. If I had a 9 by 2, the area is 18 square, say Cheez-Its. And this one here, if it's a 5 by 5, the area would be 25 square Cheez-Its. So it's a which one would you rather have? Well, many people might say, I'd rather have the 25 Cheez-Its. It's more. But somebody who doesn't like Cheez-Its might say, I'd rather have the 18, right? So it's their justification as to which one they would rather have. But think about the mathematics that a student needs to do to figure out the math of why they would rather have one versus the other. Another would you rather? Would you rather have 8 quarters or 2 $1 bills? That'd be a great one to give to students. We're going to find out from students whether or not they know that 8 quarters is $2 and that their value is technically the same. But when we think about them, which one would you rather have? Somebody willing to share which one they would rather have?
The dollars,
Why?
if it looks like it's more.
But is it more?
Lighter to carry.
It's lighter to carry.
To carry.
It's easier to carry, right? So as an adult, maybe I do want those dollar bills. They're easier to carry. I, don't like to keep change. I often put change somewhere else. But think of, oh, go ahead.
I'd rather the quarters because I always need them for parking meters.
There you go. So you might want the quarters. I was thinking as a student, an 8-year-old, a 9-year-old, they would probably want those quarters because all of the gumball machines and the little toy machines all take quarters, right? They're always asking for quarters. So it's a great way to kind of just have a conversation with your class or with your students about, which one would you rather have and why? And so they're doing some mathematics, but they're also having to justify. And so often in mathematics, we're asked to explain why, right? Explain our answers. And so this is a great way to have students talk about, or they could even write it. If you were not all together with your students, you could have them put sticky notes up of which one they would rather have. They could write down their justification, because even if I said I would rather have the quarters, my reason for wanting the quarters might be a different reason than somebody else wanting to have the quarters. So it's definitely a routine that you can use with students to get them talking about the mathematics. And some of them are very simple, and so even if you have kids who are reluctant to participate, they may choose to participate in something like this. I do want to show you this website as well, so I'm going to jump back over here. So when you go to wouldyourathermath.com, and I know Michelle just shared that link for us, as you scroll down, you can see that it's broken out into the grade K2, 3, 5, and then 6, 8, or 9, 12. So when I click on the grade span, it brings up some of these would you rathers. And I just took screenshots of them, but you could pull them up and share them with your students. You could even print it out if you wanted to. And so would you rather have 10 minutes of free time at 9 a.m. and 15 minutes of free time at 10 a.m. or have a half hour of free time at a specific time, or just a half hour of free time? So a student might choose this because they want 2 options of free time, even though the total amount of free time is less than this one, right? This is the dollar bill and the quarters, but if you scroll down through, You can see all these different ones, and they're great kind of, I want to say, starters for conversations. Would you rather have 364 jelly beans and give 188 to friends, or have 281 jelly beans and give 137 to friends? So they're going to do some mathematics here and figure out maybe which one, if they like jelly beans, they might figure out which one gave them more. If they think about wanting to share more with friends, they might share that way. But there's lots of different types of problems. Here, they're given 2 stacks of money and they need to figure out which one they would rather have. So they're going to be calculating the value of that money. I'm going to go back and go to the 3-5. Have a box of chocolates with 5 rows and 14 columns, or 7 rows and 9 columns. So starting to look at multiplication. A weight worth of quarters, or different weight worth of nickels. This one had to do with lemonade and juice boxes. Again, the quarters and money shows up in this one. Would you rather read 12 pages every night in a chapter book with 144 pages, or read 50 pages 3 times a week with a chapter book with 132 pages? So gets them thinking. A lot of them do have to do with food. And so just to be aware, I tried to pick one that did and one that didn't when I used the Cheez-Its and that, but a lot of them do have to do with candy. Very engaging for students. However, I know some schools don't want to kind of bring up those options, and sometimes they choose to do things away from food. But here's, would you rather have in your bedroom, size and shape? So these are just great conversation starters, sentence starters for students. And then let me go back to the next routine I want to share. Are there any questions about the would you rather routine? All right, we're going to move on to estimistry routines. So this is from stevewybarney.com, and I'll take you there and grab that link for you in a couple of minutes. But in an estimistry routine, we are working on our estimation skills. And so in this routine, this one is, I don't know if it's called flying cars or something like that, but in this routine, I want you to think about how many cars are there in all. So if you're, as you're watching, think about in your mind, how many cars do you think there might be? And as the clues appear, we're going to use that information and we'll narrow down the possibilities, and we're going to use that information to help us figure out how many cars there are. So think about right now, write down, or if you have a piece of note paper right handy, write down how many cars do you think there are shown in this picture. And I'm going to give you 5 clues to help narrow it down. So clue number 1, if I count by 2s from 2 to 60, the answer is one of those numbers. So if I'm counting by 2s, I know that I'll land on that number. So what do we know from this clue? We know it has to be an even number, right? So if you estimated and you had an odd number, you could readjust to make your estimate. And if we counted from 2 to 60, my answer is going to be one of those numbers. So I know right now that obviously it's more than 2, but it's also going to be less than 60. And this site here is stevewybarney.com. I'll take you there and I'll give you this link. But these are called estimistries. I see that in the chat box. My next clue is that if I count by 3s from 3 to 60, the answer is one of those numbers. So not only is it a multiple of 2, or if I count by 2s, it's also going to be a multiple of 3. So when I count by 3s, I'm also going to land on that number. So now I can start thinking about when do when are numbers both even and a multiple of 3, right? Like if I look at this list of counting by threes, I know it's not 3. It can't be 9 because those are not even numbers. So now I'm down to numbers like 6, 12, 18, 24. My next clue, the answer does not include the digit 0. So I know that it can't be 10, 20, 30, 40, 50, 60. So those numbers are out. So I'm still refining my estimate. My next clue is cross out any number with a digit that matches the number of cars that are flying above the cup. So since there are 5 cars flying above the cup, I know that I can't have a 5 in the tens or in the ones. So it cannot have the digit 5 in the number. And then my final clue, cross out any numbers that include the digit represented by the die. So there's a 2 on that die, so I know the number cannot have a 2 in it. So it cannot be 20 something or something with a 2 in the ones place. Does anybody have an answer they think works? You can put it in the chat box if you would like. I see 48, 36, 36, 48. All right, so then after we've seen all these clues, we've refined our estimates. We're going to think about the numbers that are left, and we're going to think about which one would be the best estimate. And I think all your estimates are good estimates, but the answer is 48. So there are multiple answers that could be true of all those clues. However, some might be more or closer to the actual estimate than others. So this is just one of the estimistry routines. You could do this all together just like we did. It's an engaging way to have students work through it. And I would stop along the way and give students more time to refine their estimates. But you could also do this in an asynchronous setting where you are not all together. Maybe you're doing something virtually, and on Monday you give them clue 1, and on Tuesday you give them clue 2, and on Wednesday you give them clue number 3, and they keep coming back, right? Because they want more information. And then eventually maybe on Friday you do reveal the answer. Some of them only have 4 clues. Some of them have 5. Maybe it's just a bulletin board that you set up in your space or in your classroom or outside your classroom, and you put up 1 clue every day, and they can make their estimates. They might put sticky notes up and put their estimates on those, and as they refine, they can change their answers. But it's definitely a way to engage students. I do have another one set up, so we'll do another one real quick. So this time we're estimating the number of erasers that are in the vase. So think about how many erasers you think might be in this vase. So you can write down your estimate. And the nice thing about these estimistries, the PowerPoints are already prepared for you. So you just have to download it, and it's a PowerPoint with all the actions. All you have to do is click through. Julie, I love that you could give them a 100 chart to cross off the ones that don't work. That is a great strategy for students. In this case, you might have to give them something bigger than a 100 chart if there's more than 100. So let's look through these clues. So the answer is less than 200. Okay, so we know that. We know that it's less than 200. So maybe you give them a 200 chart. The answer does not include the digits 7, 8, 9, or 0. Okay, so it's not in the hundreds place, it's not in the tens place, and it's not in the ones place. So there's no 7, 8, 9, or 0. The answer is 100 more than a multiple of 7? So we know that if it's a multiple of 7, it's 100 more than that. So we know that, we already know now that we're going to have more than 100, right? We know that there's more than 100 here. And our multiples of 7, 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, right? So we know it's 100 more than those. But we also know that it does not include the digit 7. We know that it doesn't include the digit 8, 9, or 0. The next clue is that the answer does not include the digit represented by the die. So again, there's no 2 in the hundreds, the tens, or the ones place. So there's no 2 in the answer. So it can't be 128. Can't be, it's not over 200, and it can't have a 2 in the ones place. And we know that the answer is an even number. So we know, if we look at these clues and we really think about an even number, we know that an even number ends in the digits 2, 4, 6, 8, or 0. But in this case, we already know that it can't end in a 2 because of the die. We know it can't end in an 8, and we know it can't end in a 0 from our other clues. So we know that it has to end in the ones place, has to be either a 4 or a 6. Good, so I'm seeing some possibilities: 114, 156, 142. So after we've seen all the clues, we can now click to reveal the answer, 114. Okay, so even though multiple numbers might fit those clues, we want to look at what might be the best estimate. So I'm going to take you to the Steve Wyborny site, and I know that Michelle shared that link in the chat box. So I'm going to click back here. So it's stevewyborny.com, and he has a lot of different routines that he shares on his website. So I'll kind of walk down through. I believe we did Splat last week or a couple weeks ago. And so Splat is also one of his routines. Here are the estimistries. I will just scroll down through the site so that you can see some of the other routines that are here. He has some more estimistries. Subitizing cards. Subitizing is being able to recognize a grouping of objects without having to count them. So it's being able to look at something and know how many. So he's got some slides that help students work with that. Splat was the routine where we looked at what was underneath. If we knew how many total, we could take away what we saw and we could figure out how many must be hidden under the splat. He has an estimation clipboard routine. So he has lots of different routines, so it's definitely a site worth checking out. But I'm going to take us back up here to the Estimistry page. And when I click on the Estimistry, I will say there are a lot of pieces that pop up here, so you just have to close them out. They're educational advertisements. As I scroll down through, this one here is just a picture that kind of gives you a hint of what an estimistry is, just like we did. But as you scroll down here, he has these estimistries already created. So this Estimistry 101, so these first ones, the level 100s, are appropriate more so for K through grade 2. You always want to check them out too, because some of the vocabulary in them, if students don't know even and odd, or a multiple or factor, or knowing about place value, they may need to help with those clues, or you may have to change those clues around. But if you click on these, it downloads the PDF for you. So I believe this was the one that we did, Flying Cars K2. But these are all different ones. If I click on them, they don't do anything other than download the PowerPoint for me. But they are all ready for you. All you do is open up the PowerPoint and you can click through the slides for your students. You can then get down to these level 200s that are more appropriate for grades 1 through 3. And as you scroll down further, there's ones that are more appropriate for 3 through 8. And again, I would make sure that you look through them before you just use them with students. Make sure that you're able to come up with an estimate that does seem to work with the clues that you're given, just so that you know that your students would be able to do that. Any questions about Estimistry? All right, I'm going to take us back to our PowerPoint. I want you to think about, if you have participated, and I know many of you have participated in our 6-week series. So going back to thinking about early numbers and countings and why we do new math through the addition, subtraction, multiplication, and division strategies, and then today with some routines. Think about what has been your biggest takeaway during this 6-week series. So whether you watched them all in person or participated live in person, or you watched them through the video, just reflect back and think about what was your biggest takeaway, or maybe there's a couple of big takeaways that you have. And if you would share in the chat box what your biggest takeaway was or is, or if you'd like to unmute yourself and share, I would love to hear what you thought of as your big takeaways from this session.
I'll go. I just on the chat shared, I think I've learned more in the last 6 weeks about math and how to work with kids than in a lot of the workshops that I've been in, not the DOE ones, but other ones. Just the resources, the examples, everything is very concrete that you shared, and that has been a huge help. So
good. I'm very glad that we were able to share something that you're finding useful and hopefully feel that you can use with your students.
Absolutely.
Great. And I know many of you have filled out other ideas in the survey, so we are taking a look at those other ideas, and hopefully we'll be able to bring you some other offerings. I'm seeing some great responses in the chat box. Thank you. We definitely have enjoyed offering these for everyone, and the videos are there. If you did not get to do some of the other sessions, not just the math ones, but just other sessions, all of those videos are also offered on our website, so feel free to go back and watch those. There's some work around pre-K strategies, social emotional learning. There were some special ed offerings, I believe, from our special ed department, multi-tiered systems of support. So those would be like interventions and how we support students, not just in tier 1 instruction, but in our additional supports that we offer for them. So those are always up there on the website as well. And I believe the intent is that they will stay there for a while. I know that we have a YouTube channel that we are working on adding more and more videos to this YouTube channel that is offered by the DOE. So all of our recordings, we are recording now and putting them up on that site for everyone to see. Does anyone have any questions before I share the final slide and the final links?
So the DOE YouTube channel, is that what we look for, or is it?
Let me take you right there and show you. So I'm going to come back here. Our website is maine.gov/DOE. And it doesn't have to say home, mine just happens to say home, but maine.gov/DOE. When you scroll down to the bottom of the page, the very bottom, we have actually linked this YouTube link right here at the bottom. And when I click on that, it pulls up our YouTube channel for the department, and you can click on it. You can see all of the videos that have been offered that we've put up on here. You can also, I know they are working on making playlists so that will categorize the videos. So for instance, early learning videos will be posted under here. If you click on view full playlist, you'll get a list of them. Mathematics, so we have a bunch of different mathematics. Actually, these videos are also housed in the mathematics, but there's a few others under mathematics. There is, I believe, a playlist that was titled Ed Tech series. So all of the videos that were done under this umbrella that we did of the Ed Tech series are being listed. I'm trying to look for it right now.
I saw it.
Oh, right here.
Here.
Yep, Ed Tech series right here. So when we click on view full playlist, you can see all of the videos from the Ed Tech sessions are all linked here as well. So there's lots of different avenues to find these videos, but our YouTube channel is the easiest place to find everything that we've uploaded. I'm gonna go back here. I will now share with you the link for the survey. I do want to say it's a little bit different for the contact hours. And I see in the chat box we said our contact hours available. Most of the sessions being offered, I believe, do have contact hour links for them all from the YouTube channel. Everything that we have done for mathematics does have a contact hour certificate linked to it. I know that other areas, some do and some do not. It was up to kind of the person recording whether or not they chose to use those or not. Let me grab the link for today's session. And like I said, I want to let you know that today's contact hour certificate is going to be a little different because you won't be able to get into the survey because it lives in my Google folder, which we had trouble with. So I have thankfully already created a new way to get your survey to you. It was pre-planned, not for this necessarily, but it was a great backup to have. So when you click on this link, and here is the link in the chat box, what it will take you to will be the survey. When you click submit in the survey, you'll be directed, it will say thank you for your response. To print your contact hour certificate, click here. It will give you a link to click on. You'll need to click on that link and go to the certificate. You will put your name in and you will print your certificate from that page. So I will not be sending a certificate to you for this third session. It literally will be you printing your own certificate, putting your name on it and printing it. It will have the name of today's session on it, just like before. It should look just like the certificates that you've gotten. You can save it and print it at another time. So when you put your name in, you can save, but you'll want to make sure that you print your certificate. If you don't have a printer, if you just save it, if you save it, you could save it as a PDF, or you can just save it. It should save as a PDF. And then you'll be able to either email it to some place that you can print it or email it to somebody who needs to view it. But you will be responsible for your certificate at the end of the survey this time. Sorry to change things on you, but I'm glad that I had a backup plan set for you. So I'm gonna stop sharing.